Section 4.4 and Section 4.5, the right triangle. Here we have a general picture of the right triangle. The angles are capital letters, A, B, C. The sides are labeled with small letters and they appear opposite of the angles. So angle A has side A, angle B has side B, and angle C is the hypotenuse with side C. If I label my angle in the corner next to A, my sides will be labeled adjacent is right next to it, and hypotenuse is across from the right triangle, and the opposite side is over between BC. If I'm looking at the reference point from angle B, nothing changes as far as the lettering ABC, but what does change is the way I label my sides. The hypotenuse is still the hypotenuse. The adjacent side now is BC, and the opposite side is between A and C. Again, the opposite side is opposite of your reference angle. In this case, theta is on B. So the things I can work with are the Pythagorean theorem, which is c squared equals a squared plus b squared, or solving for c, that's equal to the square root of a squared plus b squared. A squared is equal to c squared minus b squared, or a is equal to the square root of c squared minus b squared. B squared is equal to c squared minus a squared, or b is equal to c squared minus a squared. This will help me find side measurements. I can also use the sum of all angles as 180 degrees in a triangle. I can use the trig functions. The sine of theta is opposite over hypotenuse, the cosine of theta is adjacent over hypotenuse, and the tangent of theta is opposite over adjacent. So any combination of the things that are listed are going to help me solve the right triangles. As an example, given the right triangle, find everything. So here the angle given is at A, and they give it as 28.3, and they also give the opposite side, the length between BC, or side A, is 8.5. So what I have to find is angle B measurement, I have to find side B measurement, and I also have to find the hypotenuse length measurement. So I'm going to label all my sides according to the given angle. The given angle was A, so side B is now my adjacent, side A is my opposite, and of course the hypotenuse is always across from the right angle. What I can use first is the rule that the sum of the angles is 180 degrees. So since I know angle A and angle C is 90 degrees, I can say angle B is 180 degrees minus 90 degrees minus 28.3 degrees, and that gives me angle B is equal to 61.7 degrees. The next thing I want to do is use my trig functions to help me find some lengths of sides. I can't use the Pythagorean theorem yet because I need to know two of the three sides in order to solve for the third side. I only have one side given, and that is 8.5, so I need to know another side. So what I can use is the sine of angle A is opposite over hypotenuse. Why I'm picking sine rather than cosine or tangent is because I know my opposite side. The opposite side has a measurement of 8.5. I know angle A, it's 28.3, so the only thing I don't know in this equation is the hypotenuse. So plugging in, the sine of 28.3 degrees is equal to 8.5, which is my opposite side, over hypotenuse. Reworking this algebraically and taking the sine of 28.3, the sine of 28.3 is 0.474. Reworking it, I get the hypotenuse is equal to 8.5 divided by 0.474, or the hypotenuse is equal to 17.93. Pretty much, when your variable is in the denominator, like it is here, this becomes a division problem between 8.5 divided by the sine of 28.3, and that's what I have here, 8.5 divided by 0.474. The hypotenuse is side C, so I just found side C. Now I can use the Pythagorean theorem to get side B. Side B is going to be c squared minus a squared, so I use the 17.93 squared that I just found. I subtract the 8.5 squared that was given. Subtracting that gives me 249.23, take the square root of that, I get side B is 15.79, and now I have all the information I need. You can always remember as an error check that the hypotenuse length is always the biggest length, just in case you make a math mistake. Let's try another one. Solve the right triangle given angle B is 46.9 degrees and side C is 26.2 degrees. So keeping the triangle in the same position, I now put angle B as my reference angle at 46.9 degrees. That makes my side A the adjacent side and side B is the opposite side. And the hypotenuse is 26.2. So I've labeled my sides, and again I'm going to pick my sign, the sign of angle B, and I'm picking it because it says opposite over hypotenuse, and I know my hypotenuse, I know angle B. The only thing I don't know is the length of the opposite side. So putting the numbers in that I know, the sine of 46.9 degrees equals side B, which is my opposite side, divided by my hypotenuse, which is 26.2. Now the unknown is in the numerator, so this becomes a multiplication problem using algebra to solve for B. It's going to be 26.2 times the sine of 46.9 degrees, and that comes out to 19.3. So I take the sine of 46.9, multiply that by 26.2, and I get 19.3 for side B. So now I have side C and side B. I can use the Pythagorean theorem to find side A. Side A is going to be equal to the square root of C squared minus B squared. So putting my numbers in, 26.2 squared minus 19.13 squared. Adding those up, I get 320.48. Taking the square root of that, I get side A is 17.9. Let's try another one. Solve the right triangle given little b is 1.25 and little c is 3.62. This time they don't give me an angle to work with, but I still label my triangle. I put in the numbers I know, and now I'm going to randomly pick an angle that I want to work with. So I want to work with angle A, so I'm going to label the triangle according to angle A. So that's what I did in the second picture. Labeling my angle A, I have the adjacent side, which is side B, and I know that number is 1.25. I have the hypotenuse is 3.62, that's my side C, and my opposite side, which is side A. So what I'm going to do is, if I look at my sides, I know my adjacent side and hypotenuse side. Adjacent and hypotenuse belongs to cosine. So the cosine of theta is adjacent over hypotenuse. Let me just correct that. Adjacent over hypotenuse. Cosine of A is adjacent over hypotenuse. I'll put my numbers in. The adjacent side is 1.25. The hypotenuse is 3.62. You'll notice that in this case, I'm looking for angle A. So in order to find the angle, it's the inverse cosine, so it's the second function. So when I do my division of 1.25 divided by 3.26, or 3.62, I go inverse cosine, and that gives me angle A is 69.80 degrees. Of course, I want to make sure I'm always in degree mode for any of these calculations. Once I have the angle A, I can then use 180 minus 90 minus angle A is going to give me angle B. So that's 20.2 degrees. The last thing I need to find is side A. Now I can go back to the Pythagorean theorem and say side A is the square root of C squared minus B squared. Putting my numbers in, 3.62 squared minus 1.25 squared. That's going to be the square root of 11.54, which comes out to 3.4. Now I have all the information I need. Solve the given triangle. Given angle A is 49.5 degrees and angle B is 40.5 degrees. So I put in the information I know, and then because I don't have any side information, I just don't have enough information to solve this. There's really nothing I can do. I can't find any of the sides. So this one is not solvable. There's just not enough of information. Section 4.5 deals with two special types of angles. One is called the angle of depression. The other is called the angle of elevation. The angle of depression is the angle between the horizontal and the line of sight when the object is below the horizontal. So you can see here, this is the horizontal up at the top, the object is below, and this right here is the angle of depression. But usually when you're doing these problems, you need this angle here. So the other angle is found by just taking 90 and subtracting the angle of depression. The angle of elevation is the angle between the horizontal and the line of sight when the object is above the horizontal. So here I have the object is above the horizontal, the line of sight is going up to the object, and that's my angle of elevation. As an example, a robot is on Mars. The angle of depression from a camera in the robot to a rock is 12.46 degrees. The camera is 143 centimeters above the surface. How far is the camera from the rock? So I draw my line of sight, and this right here is my angle of depression, but I really need this angle here. So I do 90 minus 12.46, that gives me 77.54. From the camera to the rock is the hypotenuse distance. This distance right here is 143 centimeters. That's how high up the camera is. So what I need to do is label my sides. So according to this angle here, I have my adjacent side and my hypotenuse. So I'm going to use the cosine. Cosine is the trig function that deals with adjacent and hypotenuse. So the cosine of 77.54 degrees is equal to my adjacent side, which is 143, divided by the hypotenuse, with this x. So again, I'm looking for x that's in the denominator. This becomes a division problem between 143 and the cosine of 77.54. So when I do that division out, I get 662.78 centimeters. So depending upon how they want me to round it off, if they want me to round it off into whole numbers, I would type in 663 centimeters. So just check on the rounding on that problem. And finally, this problem deals with the angle of elevation. How tall is the building that casts an 80-foot shadow? So I've labeled the 80-foot shadow when the angle of elevation is 32 degrees. So here, when angle of elevation, you don't have to look for any other angle, you just pretty much use that. So if I want to see how tall the building is, that's this length right here, that's my x. When I label my sides according to the angle of elevation, I have my adjacent side here, this is my right triangle, and this is my opposite side. So if I'm using adjacent and opposite, that belongs with tangent. So the tangent of 32 degrees is the opposite side over the adjacent. I've labeled my opposite side as x, and my adjacent side is the 80 feet. So the unknown is in the numerator. This becomes a multiplication problem. So x is equal to 80 times the tangent of 32 degrees. So I take the tangent of 32 degrees, multiply it by 80, and I get 49.98 feet. And this particular problem says to round it to the nearest foot, so I would type in 50 feet.